Hello, this is Barry Coombs for ComputerWorld. Thank you very much for joining me on this video where we're going to look at an introduction to network virtualization, what it means, why it's a growing trend at the moment, and how it could relate to your specific data center. So without any further ado, I'm just going to share my screen where we'll be going through a presentation. Hopefully it won't be a death by PowerPoint, but it'll be kind of thought-provoking and help you really understand how network virtualization will work in your environment. So first of all, I'm going to ask you some really random questions, and I'd like you just to write down the answers, and we'll come back to them during the presentation. So first of all, which of those on screen is more secure? Is it the castle with the moat and the drawbridge, or is it the Las Vegas hotel that we've got on the right-hand side? No more detail for now, just write down the first answer that comes to your head. Some more questions then. So if you were to think about your data center, about your infrastructure, about your environment, which network manufacturers do you use? How do you go about securing and monitoring your network? What tools do you use? What appliances, what hardware do you use? And how many virtual machines and hosts do you have in your infrastructure today? So we've seen a large amount of trends happening in the data center. There's been a big focus within IT as to how we can consolidate, how we can save money, how we can optimize the workloads that are running inside our data centers. So the first major trend was probably we virtualized our servers 5 to maybe up to 10 years ago. And we moved from a larger amount of physical servers to a smaller amount of physical servers that were now hosts with a hypervisor running on them, with the virtual machines running on top. Now, we probably went from, if you say you had 300 physical servers, we've probably got 30 or less hosts inside your data center today. And those virtual hosts, probably over time since you were virtualized, maybe you've had to add a few more. But if we actually have a look at the total number of servers, whether they're physical or whether they're virtual, it's highly likely that you actually now have more servers in your data center than you did when they were all physical. Now, that's for a variety of reasons, because once we virtualized those servers, it was so much easier for us to be able to right-click, create another virtual machine, clone a virtual machine from a template. So when we had the choice, do we want to put that front end and back end on one server, or shall I split those apart? That decision is now really, really easy for us to make. But we also have a little bit of virtual machine sprawl. It's so easy to create virtual machines. We end up creating virtual machines for virtual machines' sake. But it's ultimately very, very simple, very quick, very easy to be able to manage, maintain, grow a virtual infrastructure. But obviously that virtual infrastructure is completely worthless without the glue that's holding it together, without the network. And if we actually look at what's changed in that network, we've probably gone from 100 meg to a gig, maybe we're now at 10 gig. And looking to the future, we're looking to go for 25 gig, 40 gig, or 100 gig. But ultimately, what else has really changed within our network infrastructure in our data center to be able to keep it up with the demand of the virtualized infrastructure? You may have invested in some newer technology like the Cisco Nexus switching at the physical layer that offers you the ability to drive the network via policies. However, actually what has happened with the virtual network? The virtual network is really, really important now. It's the bit that bridges the virtual world with the physical world. So we need to make sure we're getting that right. So we need to start taking it seriously. Now, let's go back to one of the first questions I asked you. Which network manufacturers do you use? How many of you said Microsoft or VMware? Actually, port for port, VMware probably is one of the largest network manufacturers in the world when you consider how many virtual ports there are in the world against how many physical ports that are running in the data center. And it is really important that we kind of change our thinking about this and understand actually how it works. So what I want to do is just kind of go through how a virtual network works so we're very clear with it. Now, what you can see on screen, and if you just follow my mouse, we have 3 VMware ESXi hosts. Those are all connected via the virtual switch, via uplinks, down to the physical core, and then obviously from there onwards and upwards out to firewalls and routers, whatever the specific topology of your network is. Now, first of all, I just want to have a look at how some of those journeys go inside your data center, how some of those virtual machines talk from virtual machine to virtual machine. Now, first of all, if we take this first virtual machine here, it's connected down to the red port group inside the virtual switch. So this is probably allocated to a specific VLAN inside your environment. It's then connected down to the core switches, and we want to talk to another virtual machine that's on the same VLAN. So we're going to come up via the uplink into the virtual switch, into the same port group, and then we're able to talk to the virtual machine. We'll call this virtual machine number 3 on the second ESXi host. They're both on the same VLAN. We've not crossed any boundaries. There's probably not going to be any firewall rules or anything like that between those, assuming they're on the same subnet. Now, if we take that same journey from VM1, but this time just go to VM2, which is running on the same host as the first VM. So it's going to go down to the port group and into the vSwitch, but because it's on the same host, we don't actually have to go across the physical network. It's able to come straight back up and in to the second virtual machine. And this is where part of the problem lies. When we're coming down from one virtual machine down to the physical network, we are able maybe to implement rules, firewall rules, or maybe able to look at the way that traffic is going, maybe monitor that traffic. In the example here, where some of the virtual machines are able to talk amongst themselves, exactly the same could be applied between VM3 and VM4 here. The physical network isn't aware of it. And one of the main problems is when we're looking to secure, manage and maintain our network and also monitor our network, there is a lot of investment going on down at this physical layer. But if we're not truly able to manage and maintain and monitor the traffic at the virtual layer, we're missing probably what is the most critical area of your network. Now, just to follow through a couple more scenarios here, if virtual machine 1 here wanted to connect to virtual machine 2 over here in the green port group, the traffic would come down via the port group to the vSwitch, down to the physical switch, maybe then be routed between the two VLANs with some routers, or maybe routed inside the switch, and then up to VM2 on the green port group. But if we wanted to do the same journey here and go from VM1 via the red port group into the vSwitch, and the destination we were trying to end up to was VM1 in the green port group, because we are moving from one VLAN to another VLAN, so at layer 3 we need to route the traffic. That traffic is going to come down to the port group, to the vSwitch, to the switch or the router, and then back up. So it's important that we know inside our virtual infrastructure and work with our networking counterparts, or if you're in charge of the network, we actually understand the flow inside the virtual infrastructure. Now, what we've designed here on screen, what you can see here on screen is pretty typical for most virtual infrastructures. And what we are using, we can see that there is a virtual switch configured on each of the ESXi hosts. This is referred to as a standard vSwitch in VMware terminology, and we have to manage, maintain, and create these virtual switches separately in this individual scenario. So I'll go back to that question, which networking manufacturer do you use? As we can see there, all of our virtual machines are now having to rely upon the virtual network to get them to the physical network. So actually, as we've already said, VMware is probably one of your biggest networking manufacturers today, but are you really treating it as such? Now, inside of our data centers, we are seeing a huge amount of growth in terms of traffic. So what we've drawn out here is probably a typical environment. We've got our free ESXi host, we've got some switching, we've got edge security, so a firewall connecting us from the big bad wide world outside, and we have the desktops that may be connected to the data center between some firewalls, certainly some VLAN level security access control lists. But lots of us are actually bringing the desktops now inside the data center with things like shared desktop and VDI. So what we're seeing actually happen is we're seeing a large increase of east to west traffic. As we add more virtual machines, as we split more of those roles out, there's more of a need for virtual machines to be talking to virtual machines east to west. But most businesses will only invest in terms of security, in terms of north to south. We spend a lot on firewalls and making sure that we're keeping the big bad world out. But what happens if they are actually getting into your virtual machines, getting into your desktops, and then just using that as their attack vector? And certainly this is the way that we're seeing a lot of attacks working, moving from virtual machine to virtual machine. So how do you secure and monitor your network today? What tools are you utilizing? And are they aware of the virtual network itself? Now, some of the features at a basic level that you need your virtual network to be aware of are only available in the distributed virtual switch model. Now, it's available in VMware Enterprise Plus. It's also available if you buy VMware NSX alongside your existing version of vSphere. And as you can see on screen, it offers you a number of different tools, protocols, functionality that allow you to monitor the network, allow you to contain the network, such as network I/O control to allow you to set how much virtual machines are allowed to utilize the network. Quality of service is probably a more realistic one, so you can make sure that end to end you're applying quality of service for important traffic, maybe things like IP phones and things like that. We also have elements like port mirroring that are really, really important to make sure that we can monitor the network and see what's going on. So the first thing is that we need to consider, should we be moving from that standard vSwitch to a distributed virtual switch? And even those customers that are using the distributed virtual switch, are you aware that you actually have these features available to you, and are you utilizing them? So on top of all of this, on top of us now gaining a lot more workload to manage, it's now virtual, we've got to understand how we monitor and maintain it. There is also an increased risk. I mean, one of the examples here is obviously the WannaCry outbreak. We all heard on the news about TalkTalk. We need to consider what we are doing to be able to protect our data. Obviously, we've got GDPR coming in next year, and that is going to further incentivize us that we should be putting measures in place to make sure that the data is safe, that we are responsible for. Now, if we look at your network, VMware, or certainly Joe Bagley from VMware, who is the CTO, refers to the network as like an egg. And I'd hazard a guess this is probably what your network is like today. You've invested a lot of money in perimeter security and firewall. So actually around the outside, it is very hard, like an egg. But actually, if I'm able to break through that barrier on the outside, and certainly some of the ways that that will be happening today is things like social engineering, somebody kind of befriending one of your employees on Facebook, using that to get some credentials, using them to maybe install a little piece of software on their machine because it's going to do something for them, and then being able to break into your environment. Now, from there, once we're on the inside, largely they are free to roam wherever they want, from desktop to desktop, server to server. And certainly in the small to medium business space, the rules that could be in place, even between VLANs, aren't. We've introduced VLANs to separate the workloads, but the access control lists aren't monitored, aren't maintained to make sure they're as robust as they need to be. And certainly, even if you do have internal firewalls, maybe a DMZ, when was the last time you actually checked those rules to make sure they were still relevant and still work for your business? So we go back to the castle and the hotel. I promised as we went through the presentation, some of these elements were going to kind of come out. So we've obviously seen that maybe VMware is one of our biggest networking providers today. We've seen if we want to monitor and manage our network, what tools are you using today? And actually, do they work with the virtual network that you have in place today? Maybe you already have the distributed virtual switch and you just need to configure it. Or maybe you need to consider upgrading from the standard vSwitch to the distributed virtual switch with VMware Enterprise Plus or with VMware NSX. So if we now take it, on the face of it, the castle is probably the one that most of you chose as being more secure. It's got big tall walls, very strong, places for us to put weapons at the top of it. Drawbridge probably comes up. We've got a nice big moat around it, maybe with some alligators in it. It's very, very secure from the outside. But actually, what if we can get inside? Once after all of that, we manage to get inside the castle. How secure is it then? Typically, it won't be very secure. We can then roam around wherever we want inside that castle. If we look at the hotel, on the face of it, it's a lovely place. We'll go there to enjoy our holiday. You walk in the front door and there's lots of facilities available for you. But when you get in that front door, don't forget, you check in, you get your security card, you get your access card that allows you then to go into certain parts of the hotel, so maybe the lift, onto the specific floor that you're staying in, into your room. And then maybe even further from there, maybe you have a safe inside of your room. So it has many layers of security that are able to check that you're going where you should be going all the way through. Now, ultimately, the most secure environment is going to be the hotel inside the castle. And that's really what we want to be looking to do inside your data center, making it secure from the outside, but also secure on the inside, that you can't just go from one place to another place because you're inside the network. It also needs to be secured. So we need to put security everywhere, but it's been very difficult, certainly in the physical world, for us to be able to put firewalls between every single workload would have been near enough impossible. It would have been far too expensive. It would have been very, very difficult to manage and maintain. Now, even in the virtual world, we could probably do that with virtual firewalls. But again, we've probably still got the same problems. It's a little bit easier to manage and maintain. Maybe the cost would come down slightly, but certainly if we are putting virtual firewalls between all the individual workloads, or indeed physical firewalls, how quickly is one virtual machine able to talk to another virtual machine when that traffic has to be routed off via a firewall, physical or virtual, and talk to another? And one important aspect inside our data centers today is the need to make sure that they are quick, they are responsive to what it is that we need to be able to do, whether that's for our employees or for our customers. So we need to be able to tackle this in a new way, in a different way. And this is where VMware NSX comes in. I hate saying the title of a slide while I'm presenting, but VMware call this the next generation networking model. And this is because integrated with the hypervisor, integrated with VMware ESXi, we have the critical networking components. But most importantly, we have a distributed firewall that is able to sit alongside or in path in your virtual machines between the hypervisor and the virtual machines themselves. We also have routing, obviously switching that we've already discussed, and load balancing as elements there as well. So if we kind of have a look at actually how this works inside the environment, we can see here we've got a number of different hosts, we've got a number of different virtual machines, and we are then able to isolate those workloads, or what we call micro-segment those workloads. So any traffic that is passing from one workload to another workload, so that could be from one individual virtual machine to another virtual machine, or maybe a set of virtual machines to another set of virtual machines, is able to have a number of rules associated with it, so you can lock it down to ensure it's more secure. Now, the way that actually works is also a lot easier as well. If you're used to monitoring or managing firewalls, you'll be used to going, this IP address on this port is only allowed to speak to these IP addresses on this port. Now, the way it works in VMware NSX is it can be object orientated. So you can say this virtual machine can talk to this virtual machine, and then irrespective of what network is below it, it can change dynamically. Or you can say this group of virtual machines based upon this tag or this name. So it can be very, very easy for you to deploy another server into a specific workload and be able to secure it because we're doing it based upon these tags or these objects. As we mentioned, we've also got the load balancers if you need to be able to load balance those. And we've also got routing as well. What is really important is it also integrates with other third-party manufacturers. So we can use the firewall that is provided for maybe layers 2 to 4, but maybe you needed to do some layer 7 inspection or something like that. We could choose a firewall from Palo Alto, Checkpoint, or Fortinet maybe to be able to add another layer of intelligence to that scanning that also happens in line. And as it happens in line, the delay between virtual machines when using the VMware firewall is microseconds. It is, obviously there is a very, very slight delay, but actually to most users, to most use cases, it's going to be near enough invisible. Those firewalls are all centrally managed. And because we're doing this now at all the software layer, it's really easy for us to automate deployments. Maybe you have a very large web farm, and when it gets busy, you need to roll out new servers inside that web farm to be able to keep up with demand. We can automate rolling those out, adding them maybe to the load balancer, ensuring they're secured and protected. We're also able to improve availability. So if you have 2 data centers and you need to move workloads from A to B, we're actually able to connect layer 2 networks over a layer 3 network with VMware NSX. It does that by encapsulating the layer 2 packets inside layer 3, taking it to the other side. So in maybe a DR scenario where you're using VMware SRM, maybe we can remove the need for you to have to re-IP IP addresses from A to B. And as we start looking as to how we're going to adopt the cloud, how we're going to move forward, making sure that we have all of the settings surrounding a virtual machine, whether that's storage, whether that's networking, around that virtual machine so they can then move when we move the workload between data centers. This is what the software-defined data center really is all about, and why VMware are embracing these technologies such as VMware vSAN and NSX. So in summary, we need to start taking that virtual network seriously. The demand is growing. At the moment, we've got virtual machines. We're probably deploying more of those. In the future, maybe that's containers, and there will be even more traffic going through there as the workloads get smaller, but they also increase in the amount of elements that we need. We need to protect inside the network. Gone is the day where we can just make the perimeter really secure. We now need to protect inside as well. VMware NSX has 3 core use cases: security with that micro-segmentation use case we spoke about, automation, and application availability. Now, for the majority of our customers, the security element is the one that they are choosing today. However, if you are a software house, if you roll out a lot of workloads, automation will be key to you. And if you want to improve your availability between data centers, then the application availability functionality will be important. Now, ComputerWorld are doing a lot of work with our customers on VMware NSX. What I would like to ask you to do is head over to computerworld.co.uk/NSX. You'll find resources like this video, like the white papers that we've got, but we're also doing a number of experience days where you're able to come into the ComputerWorld offices or other regional locations, and we're able to kind of dig deep into actually how NSX works, how it would work in your data center, and importantly, give you some hands-on time with the technology so you can really understand it. So I hope you found this short video useful. I hope you now are a little bit more aware as to why it's one of the biggest use cases or technologies that VMware have and how it may work in your data center.